Application 1. Motion along horizontal plane. One of the examples of Newton's second law is motion along horizontal plane. We can see this situation happen in our daily life. For example, someone pushes a cart horizontally on the floor while shopping in a supermarket. Another example is a man pushes a lawn mower to cut the grass. Now let us see the example of problem about motion of an object along horizontal plane.
First application, motion along horizontal surface. Two masses, M1, which the value is 2.5 kg, and M2, 3.5 kg, rest on a frictionless surface and are connected by a light string as shown in the figure. A horizontal force F1 12 Newton is applied to M1. First, A. Compute the magnitude of acceleration of the system, and B. Compute the magnitude of the tension T1 and T2. Okay, let us see the first application. Look at the first application. By seeing the figure here, we know that the object is rest on the floor, on a frictionless floor. So the mass of the first object M1 is 2.5 kg and the second object is 3.5 kg. The question asks you to find the acceleration of the system. What is the acceleration of the system? And the second one is the value of T1 and T2. The first thing that you should do is first FBD. So what is FBD? So this is FBD is in our previous lesson free body diagram. The first thing you should do a free body diagram for both objects. Alright, we do it one by one. Free body diagram for object 1. Okay. The first FBD. An object. For example, this is M1. So, here is M1G. Here is F1, where the value is 12 Newton. Alright, what is the value of M1G? M1G is 2.5 times 9.81. So 2.5 times 9.81. Right, the value of M1G is 24.52 Newton. And then it rests on the floor. That means this is the normal force. And here is the tension. This is 1, this is tension 2. Okay, so this is T1, the tension of the string. This is an FBD for object 1. Alright, and then look at FBD for object 2. M2. Okay, so this is the tension of the string T2, and then this is the gravitational force M2G, where the value is M2 is equal to 3.5 times 9.81. The value is 34.34 Newton. And then here is the normal force. This is N1 and this is the normal force for object 2. And then there are only 3 forces act on the object 2. Okay, for the second step, we will apply Newton's second law of motion equation, which is net force is equal to Ma for both objects. So for object number 1 first. Okay, look at number 1 and number 2 object. Okay, before we apply the Newton's second law of motion for both objects, look at here, look at the value of T here. T here. So T here, okay, T here is connected with one string. When it is connected with one string, T1 is equal to T2 is equal to T. So that means the value of T1 and T2 are same because it is connected with one string. Okay, so back to the Newton's second law of motion equation. So for object 1, okay, for object 1, the net force, so for object 1 is here, this is the object 1. The net force in the direction of motion, so this is the direction of motion. Any force in the direction of motion, we consider it positive. So here, F1 is in the direction of motion, T1 is opposite of the motion. So F1 minus T is equal to MAX. The motion is in x-axis. That's why I put here AX. Okay, so F1, the magnitude of F1 is 12 Newton minus T is equal to, here is M1. M1 is equal to 2.5 AX. Alright, so here, this is one equation. And then for object 2, when you apply the Newton's second law of motion for object 2, you will get T2, which is the only force that act on the object in x-axis in the direction of motion, okay, is equal to M2A x. So here T2 will be 3.5 AX. So this is the second equation. So here T2 is equal to T, so T is equal to 3.5 AX. Okay, so I will substitute this value inside this equation. So it becomes that here. So from equation 1, from 1, so 12 minus T is equal to 2.5 AX. 12 minus 3.5 AX is equal to 2.5 AX. And then from here, rearrange the equation. 12 is equal to 6 AX. So from here, you can get the acceleration in the direction of motion is 2 meters per second square. Okay, then you are asked to find the tension of the string. So the tension of the string, we will use this equation to find it. So T is equal to 3.5 AX, where AX here is equal to 2. So 3.5 times 2 is equal to 7 Newton. So this is the tension of the string. I will show you another application of Newton's second law in the next video. Thank you for watching.